Hello. For this video, we will briefly discuss homework 8.1 and then go over notes 8.2 and homework 8.2. Let's get to it. So on homework 8.1, most of it is multiple choice and self-explanatory, but there are four problems at the end which might be a little confusing. So you see a picture of a three-dimensional solid right here, a triangular prism. And what we need to do is take these numbers and write them on the appropriate sides of the net, or the two-dimensional drawing of the three-dimensional shape as it's kind of peeled out and laid flat on a table. So what we have to do is match up the sides. Now the easiest one on here is probably the 10, because it is the longest side on this three-dimensional shape, which corresponds to the longest side on the two-dimensional shape. So we'll label each of those long sides as being 10. Then if we look for our second longest side, which is 8, that forms the longest side of the triangular bases. So that means that we'll put an 8 right here and another one right there. The remaining sides will be the two sides that are 6 units long. So that will go here, 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 and here. So that's how you are supposed to complete these questions with the three-dimensional shapes. Okay, moving on to Notes 8.2. On Notes 8.2, we're now starting to calculate volume of three-dimensional shapes. And for most of our three-dimensional shapes, there is one fundamental formula for calculating the volume. And you can see it on the screen here. That fundamental formula is V equals capital B times H. And it's important to note here that the capital B stands for the area of the base of the figure. And we could have different shapes for the base. You could have a cylinder, which has a circular base. Or we could have a prism, which could have a triangular base, like we saw in the previous example. So we just have to remember to take the area of the base and then multiply that area by the height of the three-dimensional object. In this lesson, we're talking specifically about cylinders. Since we're looking at cylinders, we are going to take the area of a circle, because the area of the base is the area of a circle, and the area of a circle is pi r squared. So V equals B times H turns into V equals pi r squared H. So our first example, we're going to calculate the volume of this cylinder that is 5 inches high, and it has a diameter, or distance all the way across the base, of 18 inches. Please note that it does tell us to leave our answer in terms of pi. So what that means is, when we get to our answer, we are not going to replace pi with 3.14. We're going to leave it as pi. So if we get an answer that's 40 pi, 40 times pi, we're just going to leave it that way. So our volume would be 40 pi cubic inches. Okay, so first we'll rewrite our formula. So our formula is V equals pi r squared h. Then we will substitute in the values that are given. So the r is the radius. Well, the radius is half of the diameter, and the diameter is 18. So we plug in 9 for r. The h is the height of the cylinder, which is 5 inches. So we put 5 for h. Then, following our order of operations, we square the 9, and we end up with V equals pi times 81 times 5. And you can use a calculator for this, but when you multiply this out, you end up with 405 pi. And remember, as it shows right here, we're leaving our answer in terms of pi. So we are not going to substitute 3.14. This is our answer. And finally, the inches with the exponent 3 is pronounced inches cubed or cubic inches. That's the units that we're measuring in. The next example gives us another cylinder. This one is a bit taller than it is wide anyway. And the volume this time is given. So the volume is 20 pi square centimeters. Excuse me, that should be cubic centimeters. That's a typo. The height is given as 5 centimeters, and we're asked to find the diameter. So we want to find the diameter of the base, and the diameter is the distance all the way across the circular base. So this one is a little bit different because we're given the volume. But again, we start off with our same formula, V equals pi r squared h. But since the volume is given, the volume, which is 20 pi, is going to be substituted for V. So we end up with 20 pi equals pi r squared times the height, and the height is 5. So we substitute 5 for h. Notice now that we have a pi on both sides of the equation. So if we divide both sides by pi, then they end up canceling out because pi over pi equals 1. So we can just cross out the pi over pi and the pi over pi, and we're left with 20 equals 5r squared. Next, we'll divide both sides by 5. After we divide both sides by 5, the 5 over 5 equals 1, so we can cross it out. And we get r squared equals 20 divided by 5, which is 4. We square root both sides of this equation to get r equals 2. Now, that's telling us that the radius is 2. So the radius is only from here to here. But remember that the problem asks us for the diameter, so we just double the 2, and we get a diameter of 4. All right, so that wraps it up for this video. If you have any questions, send me a message on Remind. And I am not going to be available during the day on Monday, May 4th, but we'll do our normal math help session on Tuesday and on Thursday. Thank you, and take care of yourselves.